Hey guys, we're going to talk today about relative velocities, or situations in which you would have to add velocities as a vector. So for example, you're in a boat on a river and your engine is reading 20 miles per hour heading downstream. The river has a current of 3 miles per hour. How fast is your boat relative to the shore? Think about it for a second. Well, the correct answer is 23 because you're going 20 miles per hour downstream, but the river is also pushing you at another 3 miles per hour downstream. So your boat is going 23 miles per hour to somebody on the shore observing you. You know, they could have a radar gun and they could tell that. Okay. If you're heading upstream instead, with your engine still at 20 miles per hour, how fast is your boat relative to the shore? Well, that's going to be 17 because you're heading up at 20, but the river's also pushing you down at 3. So together that adds to 17 upshore. And that's what the radar gun would say. Okay. All right, next page. You're a commercial airline pilot and you've set your course, your direction or your heading, and your engine speed. Assuming a windless day as you take off and you begin climbing, assuming a windless day, right? As you take off and begin climbing, you determine that there's now a 20 mile per hour headwind. A headwind means a wind blowing towards the head of the airplane from the opposite direction. So blowing in the opposite direction as you are flying. What do you need to do to make sure you arrive at your destination on time? Well, you need to speed up to compensate for the slowing effect of the wind that you didn't compensate for at the outset. What if there were a 20 mile per hour tailwind? In other words, a wind blowing with the direction of the airplane directly from the back. Well, you might need to slow down to compensate for the effect of the wind, or you can radio ahead and say, hey, I might get there early. Is it possible I should land? And then you can decide whether to slow down or not. What if the wind is blowing from the side, 90 degrees from your direction? Well, it's going to blow your airplane off course. So you have to compensate for the effect of that wind, or otherwise you will be blown off course. Here's some just other verbal examples, okay? Relative motion happens when there is something traveling in one direction, but it is being affected by the motion of another thing, okay? For example, a person walks at her normal walking speed, but she's on a moving sidewalk in the airport. That means she's going faster than her walking speed because the sidewalk is also pushing her. A plane heads one way, but the wind is pushing on it at the same time, so the plane actually, to an observer on the ground, goes a different way. Then it's pointing as well. And also, a boat heads it one way. The water is pushing it at the same time, so it goes in the direction that combines the two velocities. How about someone's on a train and they're walking towards the back of the train while the train is moving forward? Okay, to someone on land, if they could see that person would be not going as fast as the train. A person on an aircraft carrier walking across the aircraft carrier while the aircraft carrier is moving forward. So that person would be seen as moving at an angle to the aircraft carrier compared to somebody on shore. All these problems, you've got two vectors that add together to make a third vector, and the third vector represents what a person on the unmoving ground would see happening to the plane or the boat or the person on the train or the person on the okay, and as you have noticed, there are two common scenarios. Okay, the boat and the current problems. Think back to the boat game that we played the other day in class, right? Part of that static game was trying to account for the motion of the water when aiming and determining the boat's speed. Plane and the wind problem. In the same way, an airplane pilot has to know the wind speed and direction that they are flying through so that they can account for the effect of the wind's vector when aiming and setting the airplane's engine speed. So now we're going to work two examples, but we're going to do that in a separate video. One of them is a boat in the river example, and one of them is an airplane in the wind example.